Hello, fellow NASA Hunch students and teachers. My name is Miss Brittany Koger, and I'm going to be walking you through the weight and measurement for our microgravity dice game project. All right, so you should have watched the video with Glenn and Jean talking about what this project is for and why it is so important. This project is very important for our astronauts' mental health on these long space missions that they are on. Think about being somewhere away from your home for a very long period of time. If we're going to Mars, thinking about going to Mars, that takes 9 months right now to get to Mars in a small, compact area. So they're not going to be doing research the whole time. They're going to want to do something to relax and kind of be normal and feel normal. Even going to the moon, it takes them 3 days to get to the moon, 3 full days. And Artemis is going to be going to the moon soon. So 3 full days on that small ship, we want them to be able to feel normal. International Space Station, some of those astronauts go up for 30 days to a year, a half a year, even sometimes even longer than that. They don't want to be working the entire time. They do have time to work in and kind of have some mental health time. So we want to let them play some games, and we want to design a dice board that they could play in space in zero gravity. How do you roll a dice when there's no gravity? Here on Earth, the gravity is what pulls that dice down. That is the force that pulls us down and keeps us from floating around. Well, everything's floating around in space. So how do we get that to connect to a game board? My students came up with magnets, and that's what we test in these stations is magnetism. Tested magnets, and then we tested several different 3D printed material. We tested a dice and a ball bearing, because we're looking at putting something inside a dice, either a piece of metal or a magnet inside a dice. So when we roll it, it'll either connect to a metal or a magnet base. So we're going to be doing lots of tests in these investigation stations to see which one we want and where we would like our metal to be and where we like our magnet to be. So we're going to be testing magnets, we're going to be testing dice, and we're going to see how those naturally react. And we're going to be collecting all of this data to help us design our game board in the very end. And our game board here in my class, we did it and we put it on Tinkercad. And Tinkercad is a free CAD program. It is easy to set up for you teachers. I encourage you to get your students on a CAD program. Even if you don't have 3D printers, you can still get them learning how to use a CAD program. And you're going to hear me use those measurements X, Y, Z. Those are our coordinate plane measurements for our length, width, and height of different objects. So you're going to hear me say that several times. So I do encourage you to get them on a CAD program. CAD programs are very important for our future because it's going to 3D printing. They're 3D printing all kinds of different things. So try to get them on a CAD program. But I'm going to show you exactly how we did this with my students here. So this is the weight and measurement, and we weighed and measured different 3D printed material and magnets and a dice, a ball bearing, and a magnetic tray as well in this one. So I'm going to show you kind of how we did that. I'm going to try to be quick so you can get into this with your students. First off, we talked about magnetism, and we talked about how a magnet works. We talked about how there is a north and a south pole on a magnet, and then there is a north and a south pole on Earth, and that there is a magnetic field around Earth, and gravity is all affected by magnets and force and motion. So you can tie into as many science standards as possible. Go off onto, magnetism lessons. Have them, test different magnets. We are going to be testing magnets later, so that was good. So our North Pole is always going to attract a South Pole. It's not going to attract another North Pole. They're going to repel each other. So I'm going to find my North Pole here. Oh, that's my South Pole. They connected. So opposites attract. That's a South Pole. But if I put my North and my North together, they're pushing away from each other. There is literally a force pushing them apart. I cannot get them together. Same thing with a South and a South. Your same poles are not going to stick together, which means attract. Attract means to stick together. Repel means to push away. So we talked about magnets and how all of that works. We're doing magnet tests later, but we're going to weigh and measure some of these magnets. We also learned how to use a ruler correctly. So you are going to need a ruler, a measuring tool. If you're using a wooden ruler, most of them have a metal strip in them, so be careful with your magnets. You might have to, tell your students, don't let it get stuck. You got to actually measure it correctly. So we start at the end of the ruler. There is a slide that shows you an up close of a ruler, and it breaks the ruler down into fractions and little pieces of a whole. That's what a fraction is. And it breaks it down into 16 little pieces from 0 to 1. And it shows you that up close. I work with inches here in the United States. If you're in another country, then you'll be in a metric system. And you can even do conversions and how to get to millimeters to inches, inches to millimeters, inches to feet. All of those measurement conversions, you can go off on a lesson with that. You can go off on a fraction lesson. Equivalent fractions is something you can go off on as well, because we do talk about how to read a ruler correctly. Now, we break this ruler into fourths, 4 pieces, and think about breaking a dollar into 4 pieces. You have quarters. So our first quarter, half, and then a third quarter, and then a full inch. So make sure you're using a ruler correctly and you're using that terminology correctly. Always start at 0 and move forward. Make sure your students are on the right size. We also talked about the same thing with weights. And I used a digital scale for this. You can use a push down scale, but it is very hard to get a reading because some of this is very lightweight material. So you're going to probably want a digital scale. $12 on Amazon, not very expensive. And it does ounces, pounds, all of that. So it's a very good one to have, right? And there are 16 ounces in 1 pound, just like there's 16 marked from 0 to 1 in an inch. There are 16 ounces in 1 pound. And you can even go into how many grams are in an ounce and all of those conversions as well. But I'm going to show you quickly how we did this. Like I said, I had different sizes of 3D printed material. I just went on Tinkercad and did some little rectangles of each size. I bumped it up like a half or just a little bit each time. And then we weighed and measured those. You're going to need a dice to weigh and measure. Make sure you have a dice. And that metal ball is very important as well. Just a ball bearing. I got it online as well. There's like a pack of 100 for $10. So you're going to want to measure and weigh that as well. So, all right, I'm going to show you how we did this. So you get your ruler down. And we're going to go X first. We're going to do side to side. How long is this bar magnet? I'm going to use a bar magnet. I'm going to put it at 0. I'm going to go down. This bar magnet is 3 inches in its length. All right, now I'm going to turn it this way to get its width. As you see, the width, how wide is this? That is a ½ of an inch in its width. And then we're going to get how tall it is. And the width would be our Y coordinates. And then Z is how tall it is. And that is a ½ of an inch in its thickness, how thick it is. So that would be its height. And then we're going to put it on our scale, and we're going to enter all of this in on a slide on the next slide. On the scale, it weighs 1.25. All right, so 1 1/4 of an ounce is what that bar magnet weighs. And then you can weigh your refrigerator magnets, measure and weigh all of your magnets that you have. Go into the 3D printed material. Again, you're going to do your length, how long it is. This one is 1.5 inch. How wide? 1 inch. And how tall it stands up or how thick it is. That's 2/16 of an inch in its thickness. So not very thick at all. And you can even go into measurement conversions. What can we simplify 2/16 as? And try to break it down into a smaller fraction. Weigh and measure that metal ball and the dice. And I talked to my students about the dice being a cube and the ball being a sphere and how some of those measurements may be the same. And we talked about that as well, but we weighed those. So make sure you weigh and measure all of your materials and all of your magnets, because we're going to use this information in our design phase later on. That's what engineers do and scientists. They take all of their data and then at the end they put it all together and then they develop and design something brand new. So hopefully we will have a dice game developed by the end. We're going to do lots of different investigation stations where we're going to be testing magnets. We're going to be testing dice and how a dice reacts naturally when you roll it. Dice probability, all of that is going to be in our next couple of stations. And then we're going to be designing in the end. This is going to be a lot of fun. Take as much time as you need on this. If you need to take 2 class periods or 3 class periods working on weighing and measuring, weigh and measure as much as possible. The more you get it in their head, the more they're going to know, and it's going to help them out. All right, I hope you guys enjoyed this station. I cannot wait to see you at our next station. We're going to be testing dice, how they roll, and we're going to be testing magnets and see how magnets react naturally. All right, so have fun, guys. I hope to see you later. Have a good one. Bye, guys.